In our final code sample here for chapter 13, we are going to, well, 13A, so the first half of 13. We are going to bring you to what would be current with the complexity that we are going to see here in A, with classes with a separate header and separate implementation CPP files. So buckle up because we're going to take this one piece at a time really granularly so that we can squeeze everything that we need to out of this. So first and foremost, we're going to look here at main.cpp because this is where really the distribution of responsibility is going to begin with. You'll notice up here on line number 2 already that we have an include that is not one of the default library includes that we would ordinarily do or see with C++ here for class. IntegerList.h is a developer defined header, and in this case it is a class definition file. So this include on line number 2 indicates to the compiler that you are going to need a class definition that exists. So we're going to follow this immediately, and we're going to come down here to our integer list.h. Now, this is what is known as a conditional inclusion, and you do need to have these two lines up at the top of your header file, and actually you'll have to remember that you will need this hash and if at the end of your header file. What this is essentially saying is another warning. It's a flag for the compiler. This is saying, look, if integer list.h does not exist there, so that's if not defined, that is line number 3. Number 4 is its new directive, define integer list.h here. So this is the header that sets up the class that we're going to need to run in our main.cpp. I feel like this is the, this is the dog that ate the cat, that ate the mouse, that ate the, this is exactly what's happening here. We're going to trace this all the way back to where we need to start. So other than, number 1, it's in its own separate header file. Number 2, we have to have the conditional inclusion here where we say to the compiler, if this is not defined, let's define it here. And here on line number 18, we are saying, yo, this is where we're stopping our new definition. Here, lines 6 through 17, this is what we would see had we done an inline class like we had in our previous code samples, just in its own new header file. So the rules here do not change. We have to define our class. We have to give it a name. We are giving it capitals to suggest to everybody involved, to suggest to C++, to suggest to me, the next developer in the chain, to you, the next developer in the chain, that this is a class or a structure. In this case, it's a class. We have our private data members. In this case, we have a pointer to list, and we have an array of elements, yada, yada, yada. So you'll notice on line number 11 here, we do have one new additional wrinkle that we did not have in our previous code samples, is this time we have a private function here. So the private member function is a Boolean for is valid, and that's one of the things I'm going to let you investigate when you come back and look through the code. I want to stick here in our discussion to the separate files, and I want to stick to a quick discussion here about a constructor, but those we can see in the separate implementation file. So next we have to track this over to integer list.cpp. So this is, like I have here indicated for you on line number 1, the implementation file for our integer class, which is referenced in our main.cpp. It gets to be a mouthful. So I have left in here from the text a little bit more than I ordinarily would, just by way of I want to highlight for you the constructor and the destructor, because that really is the wrinkle here that we had not investigated in previous code samples. Now, the idea of a constructor is to suggest that these are the things that you will need, these are the things that the runtime environment is going to need in order for your class or your, well, let's just say class, to be able to function. So once an object of that class is instantiated, so created, it's going to need certain things to be true. So if we have a constructor, that means that we have essentially built an instance of a class before runtime so that the values are initialized and those values are ready to go when we run the program. So we don't have to worry about having invalid or improper data in there to begin with, because we are going to do the initialization when we actually create that object. Now, C++, you will have noticed in our previous two code samples, did not trip all over itself when we did not define a constructor. That's because C++ will do what is called a default or a default constructor. It depends what part of the country you come from. So a default constructor is essentially the name of your class with potentially a list of parameters that you want to be initialized when you create an instance of that class. So our class here is called integer list. So here the rules are the same from when we had an inline class. So in order to be able to reference that, we'd still need to have the name of our class, colon, and then the name of our function. In this case, the name of our function is the name of our class, because this is the constructors. This is what we need, or we would like to have, when we create a new instance of that class so that we can initialize at least some of the values that we're going to need. So this time you'll see that we are passing an integer for size, because the integer list class here, you'll notice we've got a pointer to an array and we have a number of elements. So those are the two things that we know are going to be important to integer list. So here int size is going to be the size of our array, the number 2 data member that is going to be a member of that class. So first and foremost, we are creating a new integer array, and we've got the number of elements in there is size. So we're going to loop through our array here, and it's a pointer to an array there. We're going to loop through here and assign a value of 0 to those. So what is the benefit to doing this? When we run the program for the first time, we do not have to worry about bogus, erroneous data being, by nature of the storage that C++ is going to use. You will all have done this in the past sometime. Every one of you has messaged me or your other instructors and said, I'm getting weird results here. What's the reason? It's because you didn't initialize the data there. That is exactly what those 6 lines are doing. It is initializing the data that we know we need in order for integer list to function correctly. So that is our constructor. It's the thing we call when we create an instance, so an object of that class. Now here, the other side to that coin. So if you have a constructor where you build an object of a class, I think it would stand to reason, should have a destructor, a way to eliminate an object of a class and thereby reclaim the storage, the memory that we have allocated to it. So we signify that with the tilde here. So it's on line number 23, and here is the tilde. So you'll notice a constructor is the class with the class name. The destructor is the class tilde class name, just like you see here. Now, you do not have to pass any, and as a matter of fact, you will not pass any parameters to your destructor. The idea here is to let C++ know where all of that data is being stored and to simply remove it for you. So we are going to delete list, which is the list that we have here, which is really all of the storage that exists inside of integer list. The rest of this, I'm again going to invite you to take a look here at our private Boolean function for is valid. And the rest of all of this is just a set and a get element. So do remember, back from our discussion of the chapter material, we have mutators and we have accessors. We have setters and we have getters. The whole point is to keep those both implementations separate from one another so that we know when we have a class, when we are changing a value, we have a set function for it. And we know when we need to report on the value of what that variable is, we have a get function for it. That blanket separation of setting and getting, of mutating, changing, and accessing, reporting, is fantastic because it gives you the freedom to know to change one implementation, you will not have an adverse impact on the other implementation. So if you change the set, you will not adversely impact the get side of the coin for that. So finally, what happens here when we run this program is during the compile time, we're running here from main.cpp. So here, the include is going to be, and I hate to use the word again, but included during the compile time. So where is C++ going to go after this? It's going to come over here to the class header file, integerlist.h, and here it's going to say, okay, look, you can take a look, but if you don't find integerlist.h, let's use this as a definition. So boom, now we have the class that we have created as developers. So next we need the implementation of that. So for that we go to integerlist.cpp. You'll notice that these are in fact the same, right? So here inside of integerlist.cpp, because I failed to mention it before, I should mention it now, you should use any and all of the includes here that you would need and that you are not including here in your main. So for example, we are requiring IOStream because we have cout statements. We require using namespace std because we are again using, the cout statements, etc., etc. So we are including those here because as a CPP file, we need to include those libraries again. And then when those two are pre-processed and are compiled, we can finally finish here the compilation of main.cpp. Once we finish the compilation of main.cpp, we're actually free here to go through the rest of the implementation. So this line right here, the line of asterisks, is a flag. It's a marker. It lets you, the user, know that this has successfully completed. Here we are reading values into our array based on size, and that is based right there on just a number, a value that we can read into there. It literally doesn't mean anything. So again, before you proceed, make sure that you go back and check for that Boolean function. That is certainly something that will be a value to you when you get to the end of chapter exercises here.